In this video, we will learn how to calculate arithmetic mean in open-end series. But before that, we must have an idea what is the open-end series. So let's see what is open-end series. Open-end series. An open-end series is a series in which lower limit of the first class interval and upper limit of last class interval or either of the two is not known. It means in an open-end series, the case is lower limit of the first class interval is not given and upper limit of the last class interval is not given. In that case, that series is known as open-end series. This is the one case, and another case can be that either of the two, means maybe the lower limit of the first class interval is given, but upper limit of the last class interval is not given. So that case can also be of open-end series, and another case can also happen in which upper limit of the last class interval is given but lower limit of the first class interval is not given. That is also known as open-end series. Let's see with an example. So here in example 1 you can see that in this series there is open-end, means there is missing lower limit of the first class interval and there is no upper limit of the last class interval. Both ends are open in this series. In the next example you will see that there is a missing of lower limit of the first class interval, and yes, upper limit of the last class interval is given but lower limit of the first class interval is not given. So this is also an open-end series because one end is open. And in third example, the upper limit of the last class interval is not given. However, the lower limit of the first class interval is given, but upper limit of the last class interval is not given because there is no such limit above 30. So above 30 is what number? But it is not given. So this is also open-end series because the last class interval, for the last class interval, upper limit is not given. So in this, one end is open here in this case. So these all three examples are of open-end series. So we have to calculate arithmetic mean in these kind of open-end series. So let's see how to calculate arithmetic mean in open-end series in an example. So this is an example of open-end series in which we have to calculate arithmetic mean. So in this you can see that both ends of the class interval of the two class intervals are open, means lower limit of the first class interval is not given and upper limit of the last class interval is not given. So how to find out both the ends of the first and last class interval? So one thing you will see that there is uniformity of gaps between different class interval. Say, means for example 10 to 20 there is a gap of 10, 20 to 30 there is a gap of 10, and in 30 to 40 also there is a gap of 10. So in this type of series where there is an equal gap, we will assume that in the first class also there will be a gap of 10, and in the last class interval also there will be a gap of 10. So for that we can make another class interval. So as you can see that we will assume that there is a gap of 10 in the first class interval, that will be 0 to 10, and in the last class interval also we will take the gap of 10, and there will be no change in f will be the same. So this is our new series 0 to 10, and corresponding f is 5. Then 10 to 20 there is a f which is 8, and corresponding to 20 to 30 there is a f which is 6. For 30 to 40 the f is 7. For 40 to 50 f is 4. So this is our new series, and in this series now we will calculate arithmetic mean as we generally do. So for this we can apply direct method in continuous series. For that we have to find out mid value, which is denoted by small m. So for 0 to 10, if we have to calculate mid value, it will be, means upper limit is 0 and higher limit is 10 divided by 2. It means 10 by 2, and our mid value will be 5. So m will be 5 here. Similarly, for 10 to 20, our mid value will be 10 plus 20 divided by 2. That will be 30 divided by 2, which will be 15. So we will write 15 here. Then for 20 to 30, 20 plus 30 divided by 2 means it will be 50 divided by 2, which will be 25. So we will write value here, and the next, and similarly we will find our next mid value, which will be 35 and 45. So these are our mid values. Now we will multiply f with m. So fm will be 5 into 5 will be 25, 8 into 15 will be 120, then 6 into 25 will be 150, and 35 multiplied by 7 or 7 multiplied by 35 will be 245. Then 4 into 45 will be 180, and if we sum all these values we will get summation fm as 720. So this is our fm, and now we will put the formula, which will be x bar is equal to summation fm upon summation f. For that we have to calculate summation f here, which will be, let's see what is the summation f, and for that we will write this formula at some another place so that we can calculate f here. So summation f in this case will be 30, and if we divide 720, we will put 720 here as summation fm, then summation f will be 30, and if we divide it we will cancel it out, and we will get 24 as the x bar. So our mean will be 24. So 24 is our answer in this case.